So hello everyone. Thanks for getting up early and staying up late, or whichever way around it is. I guess it's getting up early for most people. I'm just going to quickly go through because someone just asked about Cloud Compare. This is the Cloud Compare downloads page. So if I've just gone to this danielgm.net/cc, and the version that I've installed is this version here, which is the Windows 64-bit installer. So if you just want to make sure that you have that, if you want to follow along, if you don't necessarily have to follow along, because we have 3 hours, so it's going to be fairly fast-paced. So if you want to just watch and then later on try and follow and ask questions through email, that's totally cool as well. I can answer questions, next week and leading into, the following weeks. Okay, cool. So first of all, actually, let me just get the chat up so I can see that you're all saying. If I just quickly open up the chat, sorry. There we go. Okay, cool. So there we go. Yeah, so I'm going to start off by, without opening the text book, I'm going to start off talking through an overview of point clouds, how they work in TouchDesigner, and then we're going to talk about how to use the Kinect Azure to control point clouds. If you don't have the Kinect, don't worry, because we have some sample depth maps of Basil, my dog, that you can use. So if you don't have a Kinect, don't worry. Kinect 2, you can. We just need to double check. I think it's pretty much the same depth map, so you can probably follow along fine. You can still get the point cloud and the color data from a Kinect 2, so that should be fine. I don't think anything else is weird, but we can answer questions. So once we've done that, once we've done the Kinect, we're going to do a little bit of creative stuff with that, do some some depth maps from that, and get camera movement and so on. And then we're going to bring some 3D scan data. These are photogrammetry scans. Basically, I just took lots of photographs and turned those into point clouds. So we have two sample EXR file, not EXR, XYZ files, sorry, in the assets folder, which I hope you've all downloaded. And that is one's of a temple and one's of a shrine that I just took nearby. This in Shibuya. So we're going to play with those. I'm going to show how to manipulate those in Cloud Compare, how we can clean up those sort of big point clouds for use in TouchDesigner. And then we're going to do a little bit of kind of creative blending between them and so on as well. So yeah, so that's preparing the 3D scan data. We're going to get that using in, and then we're going to bring that into TouchDesigner with the point file in top. And the point file in top is going to basically just bring in all that onto the GPU, and we can then work with instancing and things like that to kind of make this beautiful visual. So the visual on the right hand side here of this is something that me and Miyu have been working on. If we have time at the end, I will go through the file for this so you can have a look, and I'll show how it was kind of built and put together. But this is actually a similar sort of situation of what we're going to be doing with the point file in today. We're going to be taking some point files, blending between them, and we can have a look at doing some little camera blends to kind of move around the scene with a bit of vignette and depth of field and so on. So yeah, so that's kind of the workshop structure. So it's going to be fairly, there's no programming. It's all quite sort of straightforward in that sense. It's mainly going to be tops. There's a couple of weird little things to get your head around in terms of how to work with 3D data in a 2D top context. But I'm going to explain through, and hopefully that should be fine for everyone to get through. So I'm going to start off talking about the anatomy of a point cloud. And basically a point cloud in terms of data, they come in lots of different formats. There's every research or science institution seems to have its own format for a point cloud. So Cloud Compare supports most of them. TouchDesigner doesn't support so many. So things like XYZ and PTS might be exactly the same file, but with a different extension. And CSV is obviously just like an Excel sheet. You can just bring in Excel sheets of point clouds. But some of the more unusual ones like .fit and fits, which they use for astronomy. If anyone's seen the Grand Can project, they probably have seen the bits files that we worked on for that. And then you have things like PLY, and then the ones that TouchDesigner doesn't support, E57, LAS. There's all these weird other formats which you're more likely to find online than if you're trying to find. If you're making your own point clouds, they'll just come out as whatever you want them to. But if you're finding data sets online, then you probably want to pull in these files, which is where Cloud Compare becomes super handy as a bridge between the two. So yeah, so basically point clouds are just spreadsheets with each column representing a point attribute. A point attribute could be the position, the normals, the color, your own custom attributes if you have things, you know, which other bits of data you want to bring in, like weights or sort of forces and so on. So yeah, you can put all that into a spreadsheet and you just have a load of columns, and each column represents the value, and then we just have a million rows of points. Basically, if we have a million points in our point cloud. So yeah, so when it comes into the point file in top, it looks like this on the right hand side. We have these sort of gray and black points. This is actually the X, the Y, and the Z position of the point cloud, and they get encoded into the red, the green, and the blue color channels in a top. So pardon, because we're working on the GPU, we can only have a certain number of color channels in each of our textures, because we're basically taking 3D data and then making that a representation of that in 2D, which is what this is. And so derivative, obviously, back in the days, we would work with, in TouchDesigner, we would work in, we'd work in chops and SOPs, and it would be very heavy because it's on the CPU. So nowadays, the better workflow is generally to try and do things in tops, and derivative kind of realized this, and they've decided that, you know, we have this point cloud. If I right click, this is actually an op viewer, by the way. If I right click on it and go view as points, then we can see our point cloud representation as a 3D object now. So that makes things a lot easier in terms of working with point clouds. In fact, the right click menu, the right click context menu is very useful whenever we're working with depth maps or point cloud data. So it's just worth bearing that in mind, that it can help you a lot to be able to just hit, I think V does the, well, maybe not in perform mode, but V will normally do that in the viewer. So you can see how the points work. So yeah, so I've said that already, the point file in top, it encodes point attributes as RGB and A. So what that means is we can access 4 attributes using a point file in, or if we want, we can use a point cloud select, and then we can access more than the 4 channels, because we now have 2 tops. We can access 8 or 12 or 16, etc. And tops from the GPU, so we do all the processing on there, which I've already explained there. The tops right-click context menu, yep, so that's what I was saying here with view as points, so we can see there. This is actually just a reordered point cloud. So if you go red, green, blue, you can see all the data. The color will give us X, Y, and Z in red, green, and blue colors. So here, when we go to the top right in the point file in, we can just basically choose we want X, Y, Z, for example. We can choose those channels, and we can then decide what channels we want to go out to which tops and how we want to manipulate that, and then we'll go on from there and do some instancing. So yeah, so that's the anatomy and the sort of how things come together. The other thing is, like, where do we get like point clouds? Where can we get them from to play with? Because TouchDesigner, you know, sometimes it's good to just be able to download tools. So LiDAR scanning is the main one. When you use LiDAR scanners, you get massive point clouds of maybe 40 million points. TouchDesigner, for example, if I go back to this one here, this is 5 million points. It runs at 3 frames per second, actually, on a RTX 5000. So it's pretty heavy to run larger point clouds in real time if you're using like PBR and spheres. But if I make this just points, particles with point sprites, it'll run at about 60. So you can speed things up and slow things down depending on how you're rendering things. So actually, if you're using PBR, normally about 300,000 is kind of when things start to go downhill. So the point clouds we're working with today will be 300,000 points. So cool. So yeah, so we can bring in with LiDAR scanners. They're going to give us massive point clouds. We can then use Cloud Compare to bring those points down, the numbers down. We can actually resample in TouchDesigner, but I wouldn't recommend it because of, well, we'll go through that later, but basically from a points ordering point of view, things get a bit weird and chunky and nasty. So we can talk about that when we go through a little component that I've built. Yeah, so we've got LiDAR scanners, LiDAR stereo cameras such as the Kinect. So the Kinect and the Z are very good for giving you depth maps. And obviously there's, I can't remember the name of the other one, the Intel one, RealSense. It's like RealSense and things like that. You can use any of those. They all kind of come in very similar fashion in Touch. So they're very useful to start creating things too. Photogrammetry, which I mentioned, is what we're going to be using today. Those photogrammetry is basically just taking lots of photographs, putting it through some software like 123D or something, or Agisoft PhotoScan. And from the back of that, you get this point cloud, which you can then bring into TouchDesigner, or you can bring it into Cloud Compare, do your processing, and then come into TouchDesigner from there. So that's quite useful as well. Like that's how I took these scans we're going to be using today. Finding data sets online is another one. Actually, I'm going to show this. I'm just going to quickly exit out. A really handy tool for finding data sets or point clouds is dataset search. So datasetsearch.research.google.com has some point clouds and things on there if you just search. So actually, one of the ones that I've been using a lot recently is DEFRA, which is the Department for Environmental and Rural Affairs in the UK, have an entire elevation map of the UK, which you can download as a point cloud. So that's really cool. You can download the section you want. So you can download like a point cloud of London, for example, and it has all of the building elevation data and so on. So that's quite cool. I can't remember the name of it now, but if I search DEFRA point cloud, or if you search height maps and so on, there you go, LiDAR point cloud. So you can go in and you can explore from dataset search. It's quite useful to search in. And if you search in different languages, you'll probably get more relevant information. If you search in Japanese, and you probably get more Japanese sort of resources. So that's pretty cool too. So that's and the last option is build your point cloud in TouchDesigner. This here looks like a nice point cloud. It's actually just, if I go view as image, some noise, and the noise is just generated through the noise top. We can change the seed, we can change the period, harmonics, roughness, so we can change all those values in the noise, and it's going to update our point cloud. So that's kind of just showing that the point clouds are basically, they're brought into TouchDesigner like images, and then we work with those images, and then from that we get the 3D data. And then that comes up to this idea of images, because images in general, we work in TouchDesigner at 8-bit. And what 8-bit means is we have 8 zeros or ones, which can comprise a number of 0 or 1, or then the second one would be 0, 2, that'll be 4, 8, 16, it doubles each time, which means that whenever we have an image in TouchDesigner, the human eye doesn't really notice it, but we only have 256 values, 0 to 255 for our color channel. And what this means is if we have a point cloud where the point is minus 1.05 in the x-axis, then we can't actually represent that in 0 to 255 because we don't have, or even if we normalize that 0 to 1, we don't have minus numbers, and we don't have the resolution to really get down to that exact point. So the way we get around this is we actually use 32-bit image maps, which gives us a lot more resolution, and then we can do minus numbers too. So that gives us a bit of a conundrum in TouchDesigner, because they're really kind of annoying to view in the top viewers. So that can be explained, I think, here. So this is a top viewer, and you can see here that this is a depth map of Basil from the Kinect, and most of it's white. And the reason most of it's white is because it's viewing it like it's an 8-bit image. And if it's an 8-bit image, then we clamp everything at 1, which means anything that's further away than 1 in the depth map won't be shown. It'll just look pure white. So if I hover over, you can see the RGB values there are updating. So what that means is we can't really see what we're working with. So what we can do is, again, on the right-click menu, we can use what's called a normalized split. And this will give you your normalized values in a 32-bit space. So you can actually see a little bit better what you're working with. Another option for that is to use the math top and to bring everything from whatever your range is. So let's say we're going from 0 to 10 meters. We can come back and use the math top to bring that down to 0 to 1. So then we can work in 0 to 1 space and kind of play around with that 32-bit. And that will also be a way of kind of just quickly being able to see how things work. The last thing is, when we use viewers in TouchDesigner, by default, they interpolate between the pixels. And we'll see this when we do the first Kinect Azure example. Interpolating between the pixels just means that you get this sort of noise in your depth map, you get like this little points that are just not quite in the right place, because TouchDesigner sees those points and tries to interpolate rather than just saying nearest to the exact value. So whenever we work with tops, we have to make sure that we basically set those as static values. Yeah. Cool. So the Kinect data we're going to work with, for those who don't have Kinects, we've got this, which is my dog. We've got 4 different scans, and we can maybe like blend between those or something if you want to. But yeah, you can use these. These are the 4 scans of Basil. They're actually brought in through the Kinect in top. So the Kinect Azure top, sorry. So they can be used as well. They're static. Annoyingly, they're not movie files, but you know, it's something to kind of, we can play around with it and change things. And after that, these are the 2 scans, the 2 point clouds that we're going to use for the point file in. So this is the two photogrammetry files that I took. So yeah, we can play with those, and they've got color values and stuff as well, so we can adjust those. Oh, and there's some questions coming in there. Movie files, are they possible from Kinect? That's a good question, and that's why we don't have movie files. You can use an image sequence. You can send out an EXR image sequence, and that will allow you to basically have bring it back in, but it's going to be quite slow. So that's a bit of a problem. I mean, you can also use 16-bit. I'm not sure if any of the movie files, I know the Notch LC codec, which is available in experimental, will do 10-bit, I think. But yeah, it's one of those things that I'm not sure which movie files actually, which movie codecs support higher bit rates than 8-bit in Touch, but image sequences you can definitely do. So that's a good question. Are there any other questions before we jump in and start playing around with TouchDesigner? Nope. I think we're good. Okay. Also, if I go too fast, just say in the chat. I'm always checking the chat, so I can sometimes go very quickly. So that's just something to bear in mind. Okay, cool. So I'm going to just escape out of this. And what I'm going to do is just turn off cooking here. I'm going to start a new TouchDesigner project. And I'm going to work in 24.520. If you work in the latest official, that's cool. It's a little bit ahead of me, I think, anyway. Just maybe don't work in the experimental, because there are some camera changes in there, and it can make things a little bit weird when you're trying to follow along. So probably best to work in the official build if you can. I know there's some people, and also if you're on a Mac, then yeah, there's going to be trouble, because there always is. So if you're on a Mac and something happens, let me know, because yeah, obviously you can't use the Kinect anyway, but yeah, there's going to be a few issues with Mac. So I'm going to start a new project. I'm going to close down the palette. I'm going to delete everything out. So I've just got a clean TouchDesigner interface. So we're going to bring in the Kinect. I've got my Kinect hooked up. For those of you who don't have a Kinect, if you go into the assets folder, there is a folder called Kinect Images, and you can choose any one of these 4. There's 4 different versions. So if I bring in this one, you can see. If I bring in all 3, and that will bring in, if I just drag those in, you get color, point cloud, and depth. And these are the scans of Basil, my dog. So if you want to just follow along wherever I'm using the Kinect, I'm going to set this up basically. But for those of you not using the Kinect, you can use these PointCloud images. Will the free version of Touch work okay for this? Good question, because we're working at high resolutions. Potentially not. You can work at a lower resolution. I can show you what if this PointCloud comes in at 720p, then you can work at 720p. So I think I can talk through that as I go through. So that's thanks for letting me know that, because that's actually a good point. I need to be able to resample some things. Okay. So I'm going to start by, so if you are using the Kinect scans from here, just drag those in as these three. For those who are following along with the Kinect, then I'm going to lay down a Kinect Azure top, and you'll see that the Kinect Azure top comes in 640 by 576. So what I'm going to do is I'm going to choose the color map, and I'm going to keep it at the 1080p. So that should be good for you. So then rather than laying down another Kinect Azure, you see you get an error. It says only one can connect to a device at a time. So what we want to use is, instead we use the Kinect Azure select, and we drag the Kinect Azure onto that select. And now this is going to give us our point cloud. So if I align this point cloud to my color camera, then we're now going to have a 1920 1080 on each. Or if you're in the free version of TouchDesigner, you might only get 720p, in which case, but don't worry about that, because we're actually going to bring the resolution down. So that's going to be fine. So when I copy again, I'm going to copy paste this Kinect Azure select, and then I'm going to choose depth. So now I've got my three different images, and they're very similar to these three images here that I got from the Basil scan. And what I'm going to do is actually, I'm going to bring the resolution of this down. So yeah, so this works for the TouchDesigner people who are using 720p. So this at the moment, if you click, you can see that's 2 million pixels, which means there's 2 million points in this point cloud right now, which is quite a crazy amount of points. So what we want to do is we want to bring that down to something a little bit more manageable. So I'm going to delete out this Basil stuff. If you're working with that, you just need to work alongside as if you're using a Kinect. Okay. So what I'm going to do is I'm going to use the fit top, and then what I'm going to do is I'm going to fit everything to something a little bit lower. So let's say maybe like 1920. Let's just divide it by 3. So let's do 640 by 1080 divided by 3. So 640 by 460. So that's going to work for people who are using free TouchDesigner as well, for non-commercial. So I'm going to use a fit, and the first thing that is going to happen for my color values, it's great. I can leave it as it is. But when I copy and paste this, and I use it for my point cloud, we have a bit of a problem here in that now it's interpolating between the pixels. And what I'm going to do is I'm going to leave it like it is for now, just to show you the actual effect that has on our point cloud. And then I'm going to do the same again for our depth. We're not actually going to be using the depth much, but it's more just to kind of show, that we can use it for depth of field, but I'm probably going to set up my own depth paths for that. But we'll go through with these two for now anyway. So yeah, so the first thing we want to do is we want to be able to visualize like what is our point cloud? How does it look? So the easiest way to do that is to go to our fit, and we can make the viewer active, and I can right click and say view as points. And annoyingly, by default in TouchDesigner, for you guys, you'll notice that I can't really do anything, and that's because adaptive homing is off. So I'm going to turn adaptive homing off, and then I can left click to move around, and I can see my point cloud here, and I can see myself. And you'll notice straight away that the Kinect is basically looking directly down the positive Z axis from 0, 0. So the Kinect by default is set to 0, 0 in the positive Z axis. And this becomes a little bit tricky when we're dealing with trying to create masks and so on, because if we want to get rid of the background now, I'm no longer in the actual perfect axis to do this. I'm now at an angle, so the Z depth is not actually the Z depth, it's actually more like this. So we need to look into how we can fix that. So another thing we'll notice is we have like little points here and so on. So if I just turn off interpolate and set this to, this is on my fit 2 here. If I just set this to nearest and nearest, then that's going to clean up any noise that we might get in the Kinect. And also, actually, whilst I'm talking about that, it's worth mentioning that you will also get noise if you're in the wrong power frequency for your area. So I'm in Japan, so if I go to Kinect Azure here, if I go to the color tab, power line frequency is set to 60 Hertz, which means that if I was in the UK, then I would be happy with that because we have 240 volts going through the power supply. In Japan, I'm on 100, so I want to go to 50 Hertz, which will help for any kind of weird power line issues that we might get. So that's going to clean up a little bit of noise as well on your Kinect depth maps. That's going to help you out. You can also do things like manual exposure if you're in a dark room and so on here, but for now we're just going to leave this as it is with our standard settings. So yeah, so we got this fit. Now, what I'd like to be able to do is get rid of all this background noise, all this background stuff, and just have it so it's just me in the room. So the way we can do that is to actually use some, oh, sorry, someone's asking a question. My Fit 2 is still showing the pink blue image. Ah, yes, yeah, sorry, if you right click, if you make your viewer active, you can right click and say view as points, and that will open up a point viewer. And just make sure adaptive homing is turned off, or you can go view as image, and that's going to switch back. And V will toggle between the two. So if you want to toggle between the two, you can do that with the V key. Are we all good? I think we're good. Yeah, cool. All right, so yeah, so that's so what I want to do is I want to be able to crop off this background, and the way to do that is to use the chroma key is probably the easiest way with our different 32-bit values set up. So a lot of people will tell you you can use the threshold in the depth map, and that is one way of doing it. But what I like to do is I like to use the point cloud, and I like to use the chroma key because that means we can quite easily crop in our x-axis, our y-axis, and our z-axis, so we can give ourselves a square area to work in. So we're going to do that from this fit. So if I'm just going to set this fit back to image, and now I've got nearest pixel on my smoothness, and I want to select out the background. I want to get rid of the background. So first of all, I'm going to start with the z-axis, because the z-axis is normally with Kinect, that's the most obvious one to start with. And the z-axis is the blue color channel. So what we can do is we can actually, there's a couple of ways of doing this. One is we can chroma key and just work directly with sorry, I say chroma key, I'm talking rubbish. RGB key, sorry. RGB key, and then we can say like blue minimum and blue maximum, but you'll see like quite quickly, it's quite hard to control this because we're on this slider. So that's one issue that we're going to have. So there's one way of getting around this, which is to rearrange our point cloud to something a bit more manageable. So at the moment, we can see here that if I display the pixel values on my fit, we can see here that at the bottom left corner, it tells me that my blue channel, I'm 0.8 or 0.9. If I move backwards and forwards, you can see that it's actually, it's moving forwards and backwards as I am, because that's the depth of that point in the image. So at the moment, we're talking like 0.8-ish. So maybe if I said I want my minimum to be like 0.5, and my maximum, well, how far away does it go? It goes about 2.4 meters, 1.8 meters here. If I go on the wall, then we're getting like 1.1, 1.2. So So I think what we'll do is we'll rearrange this so that what it's going to take into account 0 to 2.5 meters. And we're going to renormalize that from 0 to 2.5, 0 to 1. We're going to do our cropping and then we're going to bring it back. So what I'm going to do is I'm going to use the math top in here after my fit. And I'm going to set the range from 0 to 2.5 to 0 to 1. And what that now means is that we're normalized in terms of our RGB key. Now, if I go blue, min, max, you can see I have much more control over the depth map in terms of how many points we want to get rid of. Now, there's a slight problem with that, and that is that when we lay down a top, like a math top, when we go to the common page, our input smoothness is interpolate pixels. We need to set this back to nearest pixel. And the reason for that is basically because TouchDesigner by default always puts everything to nearest. I've actually put an RFE in for like, it would be nice if the input could just follow through, but sadly it doesn't right now. So what we need to make sure of is we need to make sure that everything, if I middle click, is 32 bits and that everything on the common page is set to nearest and nearest for our smoothness. And it's just double check the RGB. You can see here the RGB has done it as well. So we need to make sure that everything is set to nearest pixel. So now that we have this, we can actually say, right, our blue channel, we want to kind of bring this in. We want to get rid of this background. So let's get rid of some of the background. Now the problem is that as I get rid of this wall on the right-hand side, oh, sorry, what I set the map to. The map I set to 0. It depends on what you're using. If you're using the Basil image or your own Kinect, you just want to set it to something between you and the wall. So if the wall's 2 meters behind you, set it to something like 0 to 1.8. If you haven't got a wall for quite far, then you can set it to something else. But if you're right in front of your Kinect, like within 2 or 3 meters, then just set it 0 to 2.5. And that's just going to make everything crush in, basically. Is that okay, David? You good? I think so, maybe. I'll let you, yeah, you're good, cool. Okay, yeah, so that lets us get rid of the Z channel. Now the problem is the wall to the left of me, which is here, as you can see in the depth map, that's actually less, sometimes that's actually like closer to the Kinect than I am, but I don't want that wall in my map. So actually the wall is in the x-axis because the Kinect is seeing the wall as itself in the x-axis. And the x-axis is the red channel. So what I can do is I can go into my red channel now and I can start cropping in my red channel. And you can see there, I'm getting rid of that pink section on the left. And then I can get rid of, ooh. Now my red channel is a little bit crazier for some reason. I'm not sure why. I think I need to, maybe I need to change my map a little bit because my red channel, as you can see, it really doesn't like coming in from, well, max is fine, minimum. 0.001. I mean, we've got really small values here, so I'm just gonna check. I'm just gonna check that value. So if I go here into my fit, then I can see that actually my red value is there. Oh, because it's minus 0.4. So what I want to do is actually, sorry, in my map, I want to say minus 2.5, 2.5, 0 to 1, and then I want to work with that, I think. And what I'll do is I'll do that. So that's now in all three. It makes it a little bit nastier to see, but it means that when we're using minus values for the x axis, then we can work with that as well. So if I then bring my blue, I can start working my blue channel. You can see I'm bringing it back, and then I can start working with my. If I just turn off the alpha, can I turn off the alpha on that? Nope, it's not going to let me. Okay, we'll just work with it. So yeah, so I'm going to bring my blue back towards wherever I am. So I'm just full focus, and then my red. So now when I bring my red minimum up, it should, there we go. I've got more control over how much I'm cutting off. And then my red max, I can then pull down to somewhere near me. Does everyone kind of understand what I'm doing here? Like I'm crushing in these values. I think hopefully that makes sense. Don't worry if it doesn't quite look like mine. We can You can work with just the points in the background as well, and then we can get rid of it through depth of field and stuff. So there are other ways of working. So what I've done is I've cropped out all the nonsense from my map. And I've probably lost a little bit of resolution doing that, but it's never really that major. So I just do it that way. It's better. So now that I've done that, I'm going to go in, I'm going to lay down another map. And what I'm going to do is I'm going to actually rearrange back. I'm going to put everything back to how it should be. So we've got our actual world coordinates again. So I went from minus 2.5, 2.5, 0 to 1. So now I'm going to go from 0 to 1 to minus 2.5 to 2.5. And look at that. There I am. And there's this horrible black spot in front of me. That's actually my webcam. So don't worry about that. You won't have that. It's just me. But yeah, so now we've got a nice clean map of myself with no thing around. But if I go too far, you can see there, if I start to put my hands out, that's where I've actually gone past the border, the bit where I've cropped. So you have to be quite careful about, like, if you have a room where you want someone to be tracked, but you don't want to be other people moving around behind, then just be careful that you have enough space for that person to be tracked. Okay, cool. So what's great about this is we now have this this map, and we can use this as a mask for our color channel as well if we want. What we're going to do, first of all, we're going to start doing some instancing to get this into a nice point cloud that we can then start adding shading, lighting, things like that too. So are there any questions before I carry on into that? We've got 15 minutes, I think, to your Basil can separate from floor. That's a very good point, because the reason being is that the Basil image is taken from an angle. So actually, the way the Kinect's looking at Basil is this way. But I can quickly show that just for reference. If I just bring in Basil for a moment. Yeah, so if you can see here in the image, if I view this as a point cloud, here you go. So you can see there the Basil's not actually straight to the axis. And the problem with this is that there's no real easy way. Same, yeah. There's no easy way. This is one of the annoying things right now is I've actually been talking to Rob at Derivative about this. Right now, there's no easy way to rotate or translate point clouds without doing it in the instancing. And then by the time you're doing it in the instancing, you then have to use like camera clipping and stuff to cut things off. So it can get quite nasty quite quickly. So this is something that I've RFE'd, and I hope that soon they'll maybe think about putting it in, because it's a bit of a nightmare to work with these axes when you can't actually rotate unless you get really clever with some GLSL or something like that. So the problem being is that when you're working in tops, and we'll see this when we do the next stage, doing things like sorting points and so on is very difficult. It's very difficult to do on the GPU because that's not how GPUs think as such. So for now, I think keep the floor. Don't worry too much about the floor. We'll see if we can get rid of that when we start instancing. I'm going to quickly switch out the Basil over the break and see if I can fix that. So yeah, so you might have a bit of floor in the Basil one. Don't worry about that. That's cool. In fact, I think in the one where the image that we put on the promotion, I think he has the floor, the sofa in there as well. So, okay, cool. So now what I'm going to do is I'm going to start creating. Oh, is it possible to save these point clouds offline? Yes, it is possible to save the point clouds offline. You can use a movie file out. You need to make sure you're 32 bits, and you need to set it to image. Use an open EXR and use an EXR format. And if you record that out, then you will get a 32-bit point cloud. But you'll have multiple images. If you want to have them all as, you have to have 3 images for the color. So if you want to have it all in one, you could use a layout and then crop it and so on, but it's probably easier to just send out three images. Yeah, cool. So yeah, so what we're going to do now is we're going to start instancing. So I've got this geometry component, and what I'm going to do is I'm going to lay down inside of this geometry, I'm going to lay down a sphere. I'm not going to click render yet, but what I'm going to start by setting it to mesh, and I'm going to bring its detail down to like maybe something quite low. And maybe this is a good time to save your project. because things might start to get heavy. So I'm just going to call this Kinect. So now that I've got this sphere in, I've got it 10 by 10, and I'm going to bring down the radius as well. I'm going to make it, and I'm going to make it super small. I'm going to make it like 0.0, maybe 0.001 to begin. And that's now going to be super tiny for when we want to render that as a point, basically. So I'm going to turn on the display and the render flags, and then I'm going to come back up a level outside of my geometry, and we're going to start copying these spheres onto our depth map. So TouchDesigner makes that nice and easy for us. We can go to the instance page of the geometry comp, and we can turn instancing on. And then we just need a default instance operator. So the default instance op, for now, I'm going to use this math2. In fact, what I'll do is I'll put a null after it, so we can export from the null. I'm going to call this null points. And I'm going to put this as the default operator. And then we need to give it some information as to which channels we need to map to which point attributes. So here we have translate X. We can say red, green, and blue for the translate. And you might not see anything here. Just make your viewer active and right-click home. And there I am. You can see me now. So now I'm a point cloud. Annoyingly, TouchDesigner's viewers always look this way, but Kinects in TouchDesigner look this way. Don't ask, don't know why, but that's how it is. So you can see here, I'm here, I've got my point cloud, and I can now move around. And I think everyone should be sort of getting there with that. Has everyone got their points coming like this? If you have Basil, you probably won't have any movement. Could we go a little slower? Okay, yeah, we can go a little slower. So yeah, so let me go over that again then, just quickly so you understand. Still on the sphere. Sorry. Okay, let's start from scratch. Okay, so yeah, so we're going to create the geometry, and then I'm going to go inside the geometry, and I'm going to delete out my torus and create the sphere. So are we all at the sphere level? Is anyone not at this point? Is anyone stuck? No response is good. Okay, so the sphere is a mesh, a primitive type of mesh by default. So we're going to keep that as it is. We're going to go to the detail tab, and we're going to set rows and columns to 10 by 10. Is everyone okay there? Sorry, it's really hard to follow along when we're online. I can't see people's screens or the confused look on people's faces. Yeah, so we have a 10, 10, and we have our sphere. And I'm going to change the radius of the sphere to 0.001 in each axis. So an X, Y, Z radius 0.001 for all of them. Yeah, everyone good? Okay. So then I'm going to hit display and render, so that's going to then render up to the next level. And that should allow us to see our spheres. So now we want to copy the null points onto this geometry component. So in the geometry component here, we want to go to the instance tab, and then we're going to turn instancing on. Is everyone following that? We all good? And then now that we have the instancing on, I'm going to just drag this null point. I've made a null here. I'll just do that again for the sake of clarity. So I've made a null from our math with the depth map, and I've just called this null points. And then I'm dragging that onto the default instance of. Is everyone okay there? Yeah, cool. All right, so then now that we have our null points, you're right, if I use a box, it is less heavy. But also you get really crap shading when you do PBR, which we're going to do next. That's why I've used the sphere. Yeah, so what we'll do is we will, yeah, if you use a box, and actually if you want to make it super less heavy, you can use the point sprite. You can actually convert your points to a particle, and you can actually render it as a particle too, which is a good way to do it. Especially if you're using like 5 million points, you want to be using point sprites, not spheres. But for what we're doing right now, I think we're quite low res, so we should be able to get away with some spheres. I mean, we have 230,000 points, so we should be good. Okay, so what I'm going to do is I'm going to set the null points is now the default instance op, and now I'm going to say translate X is the red channel, translate Y is the green channel. I'm just using this arrow here, and translate Z is the blue channel. And now when I go into my geometry and if I make the viewer active, then we can right click home all, turn off adaptive homing, and we can see something like this. If we start moving into our view, we should see something like this with some spheres. Is everyone following along there? Has everyone got this point cloud now? Yeah, cool, great. All right, cool. So that's good. We've got me. You got Basil. Great. I like that. So now we need to add. Obviously we got black and white. We want to add the color as well, right? So actually the color is pretty easy because the color just comes in as color. So we just use this fit. So what I'm going to do is just make sure that you have your fit set to the same resolution as your point cloud fit, because we want to have the same. We want to have the same amount of points. So what I'm going to do is I'm going to make a null after this fit, and I'm going to drag it all the way along to the same as the null points. And I'm going to call this null RGB, because color can be confusing when I spell it wrong. So null RGB is going to be our red, green, and blue color channels. And again, on the geometry comp, we can see we have all these different channels we can hook up. And if we go to the instance 2 page, we have a whole load more, and one of those is the color op. So we can go in and we can say, cool, null RGB, and we can drag that onto the color op. Sorry, I've dragged that onto the texture op, my bad, color op. So that you want that to be on here. Color mode wants to be set to replace, and then we want to choose R, G, and B. And you can see in here now, if I look in my geometry, I've now got myself with my color and my red face brought into TouchDesigner. So has everyone got their color values hooked up? Is that all working for you? I think so. No one's saying, yep, no one's lost. Cool. Pardon, I've got a bit of a cough. Okay, so now that we're here, now there's a bit of an issue in that I'm in a weird angle. So this is not very good for if we're going to start setting up cameras. Yeah, cool. So what I'm going to do is actually I would like it to be a little bit more in the center, so we can actually just send cameras around and do things that are nice. So what I'm going to do is I'm going to go to the transform of my geometry, and I'm just going to bring everything towards the origin in the z-axis until I'm kind of looking like I'm roughly across that z-axis. And I'm actually already quite central, but you might want to bring your x channel across as well. So your central and your y channel, just kind of center, just use these translate parameters, middle click, and kind of center them. And then if you want, you can also see that the rotation is kind of a bit weird. So I'm going to rotate around the x-axis. I'm going to rotate back a bit. And you know what? I'm going to just change that translate again because it broke itself. There we go. So you should have something like this on the in the center point. And I'll just give you guys a couple of moments. We've got 4 minutes left, so I don't want to get to the render point. I'll give you guys a couple of moments to get that set up, and then we'll move into how we can render this and how we can make it look quite cool. So if you make your viewer active, you can middle click, and when I say you can middle click, I mean you have to press in the middle mouse button, and then you drag either right or left, and that will zoom in or out. You can't use the scroll wheel. The scroll wheel doesn't work. Yeah, it's a bit annoying. In the new experimental, you can use the scroll wheel, but in the official, you can't. So that's why we're using this system. So yeah, so I'm going to lay down I want to lay down a render top. But the problem with TouchDesigner is that it's a bit of a nightmare to control cameras, because cameras in Touch, you have to, move them around with these middle mouse buttons. So what I'm going to do is I'm going to utilize a tool in the palette. You could use any images for the Basil picture, but you would, if you're using 8-bit images, then you might get noise. So you want to use something that's 32-bit. So if you wanted to, you could use any video, and it would come in as a point cloud. It would work. It might look a bit crazy, but yeah, you could. If you use, like, for example, a ramp that's black and white, like, like some kind of MoGraph effect, then that would probably actually work quite well as a point cloud. It would probably look reasonable. But yeah, you lose a bit of resolution on the 8-bit issue. Sorry, I was answering that question. So yeah, so what I want to do is I want to have easy control of my camera. So in order to do that, if we open up the palette on the left-hand side by clicking the top left open palette icon, the palette has this really brilliant component called Arcball Camera. An Arcball Camera is a little viewer that allows us to move our camera around easily and view things with our final rendered content rather than just what's in the geometry viewer. So what I'm going to do is I'm going to drag in this Arcball Camera. I think everyone should. Yeah, has everyone got that dragged in? I'm just going to quickly finish up. We're just about at break time, I think. But okay, so the Arcball Camera comes in, and yeah, I'll answer that question a little later. Yeah, so if we want to bring in, so we bring in Arcball Camera. If we go inside, then what we can do is we can right-click and we can delete everything except the camera, the renderer, and the background. So I right-click and drag. I want to select everything here, and I want to delete everything out. So now I just have a camera and this render and a background. So has everyone got that? Okay, yeah, cool. So what I want to do is actually right now we're not rendering anything, but what I want to do is I want to render the geometry that's a level back. So what I'm going to do is I'm just going to right click on the render and I'm going to click parameters. And this is going to open up a floating parameter window, so I can actually then go and just drag things onto that. So once I've done that, I want to come back up out of this. If I scroll out and back up a level, or you can use I and U. U will take you up, I will take you inside. I'm not sure why they named it that way, but yeah. So U and I will allow you to go back and forward. And what I can do is I can take my Geo 1 here, and I can just drag that onto the geometry parameter on my artboard, on my render, sorry. Cool. So you won't see anything by default, but that should hook up. It should go blue, and it should say something like parents 2 of Geo 1 when you drag that on. Right. So if I go right click view on this Arcball camera component, now I've got the same kind of viewer as I had in the other geometry component, but at the moment my camera's at 0, 0, 0, so we can't see anything. But if I middle click and pull out, then I should. Oh, I've done something wrong. Oh, I've done something wrong. Sorry. Before we do that, we need to go inside. We don't have any lights right now. So what I'm going to do is, we don't have any materials. So what I'm going to do is actually, before we do that, sorry, that's my bad. Before we do that, we're going to lay down a material, a matte, constant matte, and we're going to just drag that onto the geometry of the palm material. Okay. So that's now going to be the material for this geometry comp. Is everyone good there? Is anyone struggling, or are we good? I'll give you 10 seconds. We're good. Okay. So if I then right click and view this now, and when I middle click, if I hit H, it's going to home the viewer. You can see here I'm now this point cloud in this space. But the thing is, this is from the render. This is the actual rendered point cloud, not the geometry viewers sort of, this is kind of a rendering. So this will have all the lighting information, all of the actual nice materials we want to use and things like that. And that will be ready to go for yeah, the next set. And if everyone's there, then we should be good. Is there any, Yasuji, are we at break time, or should we, or like carry on?
Yeah, if you can, we can take a break.
Yeah, is that okay? Yeah,
sure.
Take a break here, and then people can ask some questions, and I can answer maybe.
Sure.
I had a question already from Rimi. Sorry if I pronounced that wrong. How to record using Azure Kinect. Okay, so I'll just quickly answer the question about that then, while we're on the break. So if anyone else wants to just chill out or ask questions, go wild. Yeah, recording out with Kinect, like I say, you have to record out an image sequence. Unless there is, let me just double check. I mean, I can probably figure this. This is probably something for me to figure out later, but I think, yeah, because animation, I don't think any of these codecs allow you to go beyond 16-bit. So you would want to send an image sequence that was an EXR image sequence to record out. We're going to go into that. Sorry, we're going to go into photogrammetry scans after this. We'll talk about that. That's it. That's the cloud compare section. So once we finish with the Kinect, we're going to move on and we're going to look at. It's a very similar technique, but we've got some other bits. But yeah, if we want to record out Kinects, we need to record out EXR image sequences. The problem with that is that it can be very, very slow. In fact, if I write one out now to see how it hangs, if I go. It's not, it drops quite a bit. So if I just go image, I think I might have just fired out an image sequence to my desktop actually. So let's just quickly, no, I didn't. Okay. But yeah, you have to basically send out image sequence. How to make it less heavy, of course. So yeah, I'll just quickly do that now. So inside the geometry, when we create a sphere, then what we can do is we can turn off the sphere. And we can use an add sop, and we can turn add points on. And what that means is that turning add points on just means that yeah, we basically have 1 point now rather than the sphere which has 82 points. There's quite a lot of points to instance for one little thing. But the problem is the add point won't render unless it's a particle with the point sprite, because only particles with the point sprites. So we have to lay down afterwards a convert. And the convert stop can be set to convert to particles per point. And then if I turn the rendering on for that, and whilst I'm turning my sphere off, we're now rendering particles rather than the original. And you can see we move a constant shader right now, it's working, and we only have the number of points that we need, which is 250,000, not the, 250,000 times 80, whatever that is, which is a lot. So yeah, so that's kind of useful if you want to do point sprite. When you want to do nice shading, like for example the promotional video, the promotional image that we use for the workshop, you want to have PBR and things. So that you need spheres or something with lighting information for that.